All right. So who can tell me what sine of 30 is? Who can tell me what sine of 30 is?
X over 2x.
So sine of 30 is x over 2x. And you got that because you were standing here at 30, right? And you remember that sine is opposite over hypotenuse. So remember that phrase. So, ka, toa. Okay. And you remember that sine is opposite over hypotenuse. So opposite side of 30 is x. Hypotenuse is 2x, so it's x over 2x. But that can be simplified, can't it? What is that simplified to? Well, the x's can cancel out, right? So I'm left with 1 on top and just 2 on bottom. So this is the same thing as 1/2. Okay. What about cosine of 30? What about cosine of 30? Remember, cosine is adjacent over hypotenuse. So it's x rad 3 over 2x. The x's can cancel out, and so this is just rad 3 over 2. Okay? And then what about tangent of 30? Opposite over adjacent, which is just x over x rad 3. Now the problem with that is, right, if I simplify that, that's 1 over rad 3. However, we cannot leave it in 1 over rad 3 form. Okay? So for 1 over rad 3, and I'm going to do this over here, 1 over rad 3, I have to make it, I have to rationalize the denominator. And I do that by multiplying it by rad 3 over rad 3. And so I'm just left with rad 3 over 3. Okay? And you know what the beautiful thing about these are? What we're developing right here? Right? The most beautiful thing about it is that these numbers are always true. So no matter what the sides of my triangles are, right, no matter how big this 30, 60, 90 triangle is, sine of 30 will always be 1/2. It never matters. Same thing with cosine of 30. It'll always be rad 3 over 2. And same thing with tangent of 30. It'll always be rad 3 over 3, no matter what. Okay? Well, let's do sine of 45. Okay? So if I'm 45, so which angle does it matter if I'm standing at? It doesn't matter. When I look inside my triangle, my opposite side is x, my adjacent side is x. If I was standing at this 45, the opposite side is x, the adjacent side is x. So it really doesn't matter which 45 I'm standing at. Okay? So using that kind of idea, what's sine of 45? Yeah. Yep. So sine of 45 is x over x rad 2. But remember, this will simplify to 1 over rad 2, which is not proper form. So kind of, again, showing you down here, if I take 1 over rad 2, I have to multiply it by rad 2 over rad 2 to rationalize the denominator. And so I'm left with rad 2 over 2. Okay, so this will be rad 2 over 2. What about cosine of 45 degrees? Cosine of 45 degrees. Yeah. That's exactly right. It'd be the exact same thing. Right? It would be, because my adjacent side is x, it would still be x over x rad 2, which we just showed simplified to rad 2 over 2. So that's the nice thing about cosine and sine of 45 degrees is they're the same thing. Sine and cosine of 45 degrees are the exact same thing. Okay? And then what about tangent of 45? What do you guys think it'll be? Anyone? Anyone? You don't. What's up? All right. Doing all right. Doing all right. So who can tell me? Tangent of 45 degrees. So what's the opposite side of the 45 degrees? Anybody? Yeah? Opposite side of 45 degrees. Sorry.
No, yeah, sorry, it's X
Mm-hmm.
over X rad 2.
Also, x over x rad 2 was opposite over hypotenuse. So tangent, remember, is opposite over adjacent. So the opposite side is x, so what's the adjacent side? It's x, right? So it's just x over x, which is 1. So tangent of 45 degrees will always be 1. Okay? All right, let's go sine of 60 now. So we're going back to the 30, 60, 90 triangle. All right, except for we're standing here looking in. Okay? What is sine of 60 degrees? What is sine of 60 degrees? X rad 3 over 2x. Okay, perfect. So it'd be x rad 3 over 2x, because again, it's opposite over hypotenuse. So it'd be x rad 3 over 2x, which simplifies to just, again, my x's will cancel out, and I'm left with just rad 3 over 2. What about cosine of 60 degrees? Anybody on Zoom?
X over.
What? Yeah, go ahead.
X over 2x.
Perfect. X over 2x, which equals what? What's it equal? What does x over 2x equal? 1/2. All right, so again, you can see that sine of 30 and cosine of 60 have the same value. Likewise, cosine of 30 and sine of 60 have the same values. Okay? Again, I just want you to notice that. I'm not going to go into much detail about it. All right, then let's go tangent of 60. What's tangent of 60? So you have x rad 3 over x, which just simplifies to what? Rad 3. Okay? Rad 3. Okay? And weirdly enough, tangent of 30 and tangent of 60 are just reciprocals. Okay? Although, again, the final form looking for this one is rationalized, right? Where we showed that it was 1 over rad 3 and then rad 3. So they are reciprocals. Okay? And then for hopefully by now, hopefully you guys remembered sine, cosine, and tangent of 90. Right? What's sine of 90? So again, now this is the part that I know is kind of confusing, because you're sitting here going, okay, well, which triangle am I working in? Am I standing at this 90 or am I standing at this 90? Okay? Truth is it doesn't matter. Because remember, sine of 90 is opposite over hypotenuse. The opposite side for both of these is the hypotenuse itself. So whether it's 2x over 2x, right, or it's x rad 2 over x rad 2, it doesn't really matter. It's the same thing over itself. So what is the actual value of sine of 90? It's 1. What about cosine of 90? Remember, if we have to choose an adjacent side, we can't choose one, right? So it doesn't matter, right? We have two different adjacent sides to choose from for these cases, right? And you could make an argument that it'd be x over x rad 2 for here, but it's not, right? I have too many sides to choose from, so I choose 0. So it's 0 over whichever number, so either 2x or it's 0 over x rad 2, okay? Either one, which means that it's always 0. And then tangent of 90 will always be undefined. Okay? Tangent of 90 will always be undefined. Whew! So an important note that I want you to think about in here is whenever we write one of these ratios, okay, it's always the ratio of a degree. So what's always in the parentheses is a degree, and it's side equals side measure over side measure. Okay? So my degrees are never outside. They're always contained in the parentheses. So for example, we have our ratio of tangent of reference angle 45 degrees is equal to side x over side x, which simplifies down to just 1. Okay? Now, one more example here before I kick you guys to your homework for today. Okay? I want you to try to write the ratios for this triangle. So I've got a 5, 12, and 13 right triangle. I want you to try and write the ratios for these ones. So I want you to find sine of n, cosine of w, tangent of w, cosine of n, tangent of n, and sine of I. Okay? Remember that phrase. So, ka, toa. All right, here we go. Let's try it. So, for number 1 is sine of n. Okay, who can tell me what they think sine of n is? So remember, n is my reference angle, so I'm standing here at n looking into the triangle. What is sine of n? Cosine is opposite over hypotenuse. What's the side opposite? Yeah,
5/13.
it's 5/13. Because no matter what, my 13 is my hypotenuse here, and it always will be, no matter what my reference angle is. Okay? Let's go number 2, cosine of W. So now I'm standing here, looking in. What's cosine of W?
Is it 12/5?
12/5. So again, if I'm standing at W and looking into the triangle, is 12 my adjacent side or my opposite side?
Opposite?
Opposite, right? But cosine, right? Remember, that's what this means. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite, opposite over adjacent. Okay? So, if I'm standing at W, right, what is the adjacent side of W? It's 5, right? And what is the hypotenuse? It's 13. Okay? So cosine of W is also 5/13. Remember, like I said, right? Something that you should notice is that if they're in the same triangle, cosine of one angle is the opposite or is the same as sine of the other angle. Okay? Now let's look at tangent of W. All right? Tangent of W. So now I'm standing up at top again. Right? Who can tell me what tangent of W is? Come on, guys. What is it? Remember, tangent is opposite over adjacent. Opposite.
12/5.
What is it?
12/5.
12/5. Perfect.
Yeah, I looked at the wrong question for 2.
Oh, it's okay. All right. Now let's look at cosine of n. I'm going to erase all this stuff here. So now I'm standing at n, looking in. What's cosine of n? Remember what cosine is. Yeah.
12/13.
Perfect. 12/13. Fantastic. Okay. What about tangent of n? Yeah. 5/12. Perfect. And then let's look at the last one, which is sine of I. So remember, what degree measure is I? It's 90. Right? And what is always sine of 90? 1. Okay. A lot that we kind of unpacked there and a lot that we kind of went through. Okay. I'm going to go ahead and stop the video, and I'm going to allow you guys to go ahead and work on your assignments for today.